Hello, today we're going to be looking at theoretical probability. There are going to be 5 topics to cover, so this is going to be a long session. I suggest when we come to the end of each section that you take a mini break. I suggest you get up out of your chair after pausing the video and you go for a quick walk, a stretch, get a drink before you come back a little bit more refreshed to go on with the rest of the sessions. Okay, the first one we're going to look at is theoretical probability. It's to do with theory. So in theory, it's what you would expect the chances to be on the outcomes. And probability is written as a fraction, a decimal, or a percentage. And you'll be asked to do all of them at different stages. Okay, it compares how many times a particular event can happen with all the possible outcomes. Remember, we have already covered sample space, and the sample space is all those possible outcomes. So our formula, total favourable outcomes, that's what we want to find, equals the number of outcomes that match the result we're looking for, and the total possible outcomes is the number in your sample space. And this is our formula. So the probability of the event, what we are looking to find, is the favourable number of outcomes over the possible number of outcomes. I suggest that you pause and you copy down this formula. Favourable over the possible, the total number. And also the total number of possible favourable outcomes or possible outcomes can never be more than the possible. So possible is 100%. All probability will be between 0 and 1, and the probabilities in a percentage form between 0% and 1%, 1 out of 100. So pause and copy down this for your information. I suggest you use coloured pens or put a cloud around this so it stands out and you can look for it. Okay, let's look at a couple of examples for you to have a go with. Okay, so we're finding the probability of these events. It says picking a red apple, so I suggest when you're doing your work you always highlight the important parts. So we're looking for a red apple, and the bowl has 20 apples, 12 red ones and 8 green ones. So we always write up our formula first. So our formula, picking a red apple, remember we said that is the event we're looking for. The total number of red apples, we're looking for a red apple, and the total number of apples. Now we've already highlighted all of that there. We have 20 apples altogether, and we said there are 12 red ones. So the probability will be 12 over 20, but we always simplify our fraction. That is something we must always learn to do now. So when you divide the top and the bottom by 4, you are going to find it's 3/5. Another way you might be asked this question is the probability. So 5 apples were picked, you would expect 3 of them to be red. That is how you interpret this information. So 3 out of 5 probably will be a red one. So if you pick 5 apples, you expect 3 of them to be red. The second type of question, we're rolling a 4, that is what we are looking for. It's a 20-sided die as a fraction, a decimal and a percentage. So our formula again, the probability of rolling a 4, that is the outcome, the event we're looking for. The number of 4s on a die and the total number of sides. There's 20 sides and there's 1 4. Therefore 1 over 20, it's equal to, that's a bit of a problem there. We'll need to make that multiply that by 5, multiply that by 5, so you get 5 over 100, which makes it 0.05 and 5%. Remember, they asked you to do all three ways. Always highlight. Now, I'm not sure if you have a copy of this, so therefore I suggest that you copy down some examples here to help you. Moving on to some examples to try. You have this sheet to work on. Now I've worked this first one. So it's 16-sided die this time, and we're going to write the percentage. So an even number. The sample space will be 2, 4, 6, 8, 10, 12, 14 and 16. So the probability of an even number, there are 8 of them if you count them up. There are 16 sides. When we simplify, it's a half. We need to write that as a percentage, so 50%. Okay. Here are some more for you to work on. Remember, it's a 16-sided die, so you work on these. Now, how did you go? If you made a mistake, go back and have a go and see if you can get the correct answer. Okay, next question. So it's 20 gaming application files on his phone, decimal. So remember to highlight decimal because that's what we're chasing. 20. So one of the 4 strategy games or one of the 12 racing games. But remember the total is 20 games. So one of the 4 strategy games, so 4 out of the 20. And one of the 12 racing games, 12 out of 20. Have a go and see how you... So, 4 out of the 20 and 12 out of the 20. How did you go? Remember, it asks you to do it to a decimal. Did you change these to a decimal? To change them to a decimal, you just multiply them by 2 so that you can get to a 10. This is a 5, we need to multiply by that 2 to get to a 10 decimal, and that helps you to make your decimal. Remember that? Okay, next question. Pause the video and have a go at question 6. Pause and have a go at question 7. This time it needs a sentence or 2, so read through very carefully. It's a sentence or 2. And the answers. How have you gone? Now, your sentence doesn't have to be exactly the same as this, but you need to have put in that the probability is greater than 100 somewhere, more than certain, it's 100% certain, it's more favourable than outcomes, therefore it's not possible. Okay? Now pause and have a quick break. We'll move on to the next session. Next we are going to describe theoretical probability. Now you've probably already got this scale, the top and bottom part, but now we've added the fraction, decimal and percentage scale. So we've added numbers to this. It would be a good idea to have a copy of this in your book somewhere for you to refer to. So it gives you an approximation. So if something's very unlikely, it's about 20% or a fifth or 0.02. No, sorry, 0.2. So you can find a number to put to your words. We're going to need those for these questions. Some examples that you have. So we're going to choose a DVD, a comedy DVD that has 2 comedies and 8 dramas. Now we've got a job to do here because the total number of DVDs isn't actually in the question. It tells you how many comedies and how many dramas, so we actually have to add them together. And the comedy, it says there's 2, so that's the favourable on the top. And then we find out it's 2/10. We need to simplify it to 1/5. 1/5 is 20%, or 0.2. So different ways of answering the question. Now it's a written question. If you want a really good mark in your exams, you need to do good communication. You need to answer a probability of 20% means it's very unlikely that a comedy movie will be chosen from the pile. Because it asks you, you need to answer the question with a chance statement. And that's how you get your good marks. Make sure you write it as a chance statement. The next example, the weather reporter. We hear these every day. 30% chance of cloudy weather tomorrow. So they're asking you to write 2 different statements. Now you must have numbers in these statements. So a 30% chance of cloudy weather means it is unlikely to be cloudy tomorrow. So 30% is unlikely. We're referring back to this diagram. Simple as that. We can use the opposite, of course. It is unlikely to be cloudy, then it is not likely to not be cloudy. So 30% chance of cloudy weather means it's likely to not be cloudy tomorrow. It's only a 30% chance, so probably less than even chance of happening. Okay. Some problems to work on. Now you need to calculate these probability and use the results to describe them occurring. Remember those sentences. Go back to your examples. So you've got a couple of questions here to look at. And some more here. We'll check question 1 first. So you worked out your probability and you wrote a sentence similar to this. That's unlikely because it's 30%. You worked out your probability for B, came out as 0, so impossible is the word, isn't it? And you've used the words from the question to answer it. It's more than even chance, 60%. And 12% is highly unlikely. Okay, checking those over, let's go back and look at question 2. So this time we're making 2 different statements. So look at the second example. So make a statement of what is happening and the other one about what is not happening. So there's some questions here for you. And some more questions. Remember, 2 statements. Okay, I missed that last question in 22. I bet you was telling me, Mrs. Booth, you've forgotten. That's all right. There's the answer to that last one. Now for 23. Remember, there are 2 statements you have to make. A and B. C, 2 statements you have to make. And yes, there is another page. Two statements for D and E. 2 statements for F and for G. Okay, quick break before we move on to the next one. are limitations to theoretical probability. That's what's telling us a perfect world where everything's fair and even. In the real world, we call them chance experiments. These things are affected by some practical results are very different. You need to understand what I've put in this circle here. So the condition of the outcome tool. Is it perfectly fair or biased for a certain result? Is it worn out or damaged in any way? Is the ground smooth or is it uneven, horizontal or sloped? Is it hot, cold, windy, calm? There are lots of things can affect an experiment, as you would know from science. So theoretical probability just tells us what should happen, not what will happen. So in real life, you know that there are things that will change the outcome. The theory is only in theory, not in practice. So an example here for you to think about. I've actually done this as an experiment with my SIP class, my maths class, and so that we used a bent coin and they had to work these out. So we did an experiment and they tossed it 50 times, and so the heads, they had 22 heads, and they were asked to compare the theoretical and the experimental probability. So the experimental probability, we got 22 heads out of 50 flips, so it was 44%, doubling top and bottom. The theoretical probability, however, is the number of heads on a coin, and as you know, the theoretical probability for flipping a head on a coin is a half, 50%. And then you had to talk about it. So since the results are not close, then the bend in the coin could have been the reason for the difference. Further trials will confirm that effect. So everybody did this and we put all the results together, and yes, we found that it was an unfair coin. So explain why the results show the theoretical probability value to be unreliable here. So that was unreliable there. Let's see. Probability says that for every 2 coin flips, one result should be heads and the other tails. Now you know if you flip a coin it doesn't go head, tail, head, tail, head, tail, because that's in theory what would happen. That is not true because other real life factors affect it. The coin may be even a little bit bent. The coin being tossed exactly the same way every single time, well, we're humans, so it's not going to happen. And it might be a different speed, it might be a slightly different height, so there are many reasons why. And a few quick questions. So compare the experimental and theoretical. Remember, you've got to do 2 lots of probabilities in this one, and how many times you would expect it to occur, and one possible cause why an experiment would be different. So you've got a yes, no here. Yes was 50 spins, it was 36. What might be wrong? Work out your probability. A clown one with 1,000. Remember to highlight all the numbers that you need to help you. 6-sided die. There's 2 questions there. And the answers. So experimentally it was 68. We know that it should have been 50. There are some reasons. Maybe there's not enough trials. Maybe it was a different starting point each time. Maybe there's something wrong with the surface. Did you come up with some more? There are many reasons why. They are just a selection. So it's not true in other real life situations because of real life factors. Now if you worked it out, the experimental and the theoretical were very different. And why? Here are some of the reasons. You might think of some others as well. And the last one, you're doing your experimental and your theoretical, and they've come out very, very different. So it should have occurred 8 times, but it did not. So there are many reasons why it didn't happen. Okay, quick break. We move on to the next one. 2 more to go. Okay, now we've been writing lots and lots of words. Now it's time to show you a little bit of shortcut. You know the words, so you'll know the shortcut very, very easily. So instead of writing all those words from now on, so the probability of the event equals the number of the favourable events over the sample space that's there. So that's in all the words that are written, and that is how from now on we can write it. So the probability of the event, and you write the event in there, the number n times of the event that we are after by the number n of the sample space. So this is now our formula. Copy that down. And here's a little example they have given you. The probability of this guy selecting a cog with a large hole in the centre at random. So the probability of the event, the cog with the large hole, is the number of cogs with large holes over the number of cogs. So if you count them up, there's 3 of them, and altogether there are 9. So it's 1/3. You have simplified your fraction as you're expected to do. Another example. Remember, always highlight the numbers. So 4 lime trees, 3 lemon trees, and 5 orange tree seeds. They're in a mixed bag. Okay, so we're going to look at the percentage, so make sure you know what you're looking for, of picking a lemon seed out. So we've got all our numbers. Now this is what would be written in longhand here. So we're looking for a lemon seed, so we need the number of lemon tree seeds over the number of seeds in the bag. You need to write it out in full so you know exactly what it is that you're looking for. That will be the same as this top one here, and the total number underneath. So you have your 3 lemon tree seeds, and you have 4, 3 and 5 seeds in there. So the total number of seeds is 12. You would need to 3/12. I would simplify that. So it is 1/4. 1/4 is 25%, which is 0.25. You could also, in a calculator, divide your 3 by your 12. Okay, let's have a go at some of these. Remember to look what the answer has to be. It's a fraction. Remember, simplest form is always expected. So all it is just doing the maths. So the probability of the event is the number of the event over the number of the sample space. So we're looking for 4 and the sample space is 5. That's in simplest form, so we don't have to go any further. Have a go at the next one. Yes, you do have to simplify it, that's correct. 24/36 will have to be simplified. Now, if you don't know your tables, you can just, they're even numbers, so keep halving them. Now 6 and 9 are both multiples of 3. So 2/3. You might know your 12 times tables and could have gone straight there or taken fewer steps. It doesn't matter. Now you have a go. This time we need it accurate to 2 decimal places. That means you're going to need to put it in a calculator. So you're going to need to, the event is 4/50. If you divide 4 by 50, 4 divided by 50, it's equal to 0.08. Have a go at the rest of them and see how you've gone. Okay, let's have a look at the answers then. So with C, 5 over 7, this is what was in your calculator. Now it's set to 2 decimal places. So just put a little line down there and look at the next number. Now 4 means you don't have to change it. So it's 0.71. Put 3 divided by 8 into your calculator and this is what your calculator will say. Put a little line just down here because it's 2 decimal places, and 5. 5 means we have to make the 7 bigger. So to 2 decimal places is 0.38. This one here, that little dot, remember, is recurring. So it would be 0.111 because it's just got ones after it and that's not going to change the 1. So to 2 decimal places you stop there. Question 3. As a percentage this time. The number of the event is 1, 2, you know that is 50%. That's an easy one. Have a go at the rest. Okay, let's have a look at those answers. It was 3 over 25. When you put that in a calculator, you will get 0.12, and that's 12%. Remember how to do that? You put 36, you divided it by 48, and this was the answer in your calculator. 0.75 is 75%. This one here, remember we said if it's more than the 2 we need, put that little line down there. That 5 means we have to, if we said we were going to round it to a whole number, that would be 63%. But we've left it at 0.5%. Question 4. Okay, fill in all those spaces and see if you can find the answer. A, B, C. And question 4. So the white flowers were 6. 10 altogether, rolling the even numbers, 50%, short straws, that's the answer. Okay, question 5 and 6. There you go, question 5. Read through it very carefully. Make sure you highlight exactly what it is that you need to be finding. That's 5A, B and C. And there is another one, 5D. Have a go at those, see how you go. Are you getting good at these? Okay, the answers. How have you gone? Getting very confident now? And question 6. And the rest of the answers for question 5. One last break. We have one last topic to cover. So have a break, make sure you have a drink of water, a bit of a walk around, and we'll move on to the last section. You're doing really well. Playing cards. Boy, do they love probability questions using playing cards. There's just so much you can do with them. So many of us have played card games, many different types, and there is a bit of luck. However, there might be a way of doing chance work in your favour if you understand the theoretical probability. Now it's important that you know what a real deck looks like. Probably a good idea to get hold of one and have a look through it. You'll see that it's split into half of them are red and half of them are black. The black cards are known as spades and they look like this, and clubs and they look like this. The red cards are diamonds, they're a diamond shape, and hearts are heart shape. Now every single one of these suits, they're called suits, and this symbol, and these are the cards in the suit. So all of them have an ace, which is counted as 1 in many games. And then 2, you can count the number of the symbols that are on each of these cards, right up to 10. Then we get into what's called the picture cards. So every suit has a jack, queen and a king. They're always in order from 1 to 10, and these often the king is worth more than the queen, which is worth more than the jack. If you count all these 10 cards and 3 more, there are 13 cards in each suit. So that means in total we have 52 cards. And no, we don't count the joker. The joker is rarely used in games, and we ignore the joker when we're doing probability. We use the standard pack with no joker. So don't worry about the joker. Now, they're all equally likely outcomes is what we're looking for. So let's have a look at calculating. So picking a heart. Now we said there are 13 hearts, 52 cards altogether, 1/4. We've simplified that. There are 4 13s in 52. Picture card. So picture card, there are 12. Remember? 3 out of each, and there's 4 suits, so there are 12 out of 52, and we simplified it, it's 3 out of 13. Those answers will come up a lot. Let's have a go. So remember, we're going to write the probability as a decimal, so make sure you understand what you're being asked to do. And remember, normal, so we're not worrying about jokers, and we've got to describe it. So all of these things need to be done in your answer. So a red card. So we remember with probability, the number of red cards over the number of cards that are in the deck. How many red cards were there? Let's go back and have a look. Red cards, 13 and 13. So how many red cards there are? 26 over 52. Now they've asked you to give you that as a fraction. So it's sorry, not as a fraction, it's a decimal, isn't it? My bad. 0.5. So then it says to describe. So there is an even chance. Now you can go right back to the beginning where we had that. And I'll put it safely over here. Remember, even, half, 0.5, 50%. So it's an even chance. We'll go back to that one. Even chance. And the question was of selecting a red card from the pack. So we had one card was selected at random from the pack of cards. Okay, so have a go at the rest of those questions. Remember, numerator is divided by the denominator for a decimal value. Have a go at the rest of these. Okay, we've done the first one. Sometimes it takes a while to become clear. So that's B down to D, mark those, go back and check, see if you can find your mistake. and the rest of them. Okay, question 2. Read it carefully, highlight the words you need. Is your sentence something like this? Doesn't have to be exactly the same order, but these words need to be in there. Highly unlikely. Ace or king of spades needs to be mentioned. Selecting from a pack, that's what we're doing. Less chance of picking the king of spades than picking an ace card. So you need to mention all those words, but the sentences can be structured differently. And the last set of questions. Away you go, you're getting too good now. These are trickier, but if you just follow what I've been teaching you, they will be easy. So there's A and B. Let's have a look. How are you going? How did you go? Getting them right? Okay, let's move on then to the last of the questions. And the final answers. Question 3 and for question 4. I'm sure you've done very, very well. Go back to any section that you are not quite understanding and have another look at it. You'll be fine. Goodbye.